Hello. What is going on? What is going on? Let's do some things. Do I need that? Oh, whoops. Oh, yeah. All right, we're going to file scope this down here. How is it going, everybody? We last night got this floating point parser code that we extracted from some larger bodies of code. And we got it working. And we're going to try replacing it. Although maybe we should benchmark it first. Maybe we'll benchmark it in the game, just to be funny. I don't know. Okay, first, let's do some basic things. All right. We're going to... I'm going to file scope this stuff. And I want to rearrange how it goes, because this mol96 stuff is not necessary to understand what is happening. So all that is going to go down here. It's going to go after. Okay. We're going to call this this. We're going to try arranging some of these things. So like, let's put that down there. Let's put okay. Okay. We almost should define isDigit because people are going to want to use that. For some reason, I just stay away from that. I don't know why I care. Okay. Okay, so Okay. It's really not that bad. Like, the basic code is up to 190 lines, like the higher level, understanding the basic thing. Then if you want to get into the fast multiply, that's just up to there. So it's 245 lines really to read floating point numbers and then a giant table. And then these things are going to be intrinsics. So it's really not that much code except for the rounding thing. Okay. So I just, well, that's not invalid. That's just, I mean, that's, whoops, that's fine. To return to have a string of all zeros is fine. Okay. So I'm just putting a few comments in here. That's all. We could, no. Like, I'm looking at this thing that we did to skip and then do this, and I'm like, we could put this like up here and assign a multiplicand or a factor, and then fall through to this. Except no, that wouldn't be good. Wouldn't be good. This is pretty weird. Oh man, some of this code was weird. All right. Wouldn't that all digits thing be 0? Oh, yeah, no, that's true. No, you're right. Right, all digits. Right, this means, okay, we got no number. We got no valid characters that could start a floating point number. How's that? How's that for an explanation? Okay. So let's actually try using this. Let's do a really stupid benchmark, all right? So in BASIC, I actually kind of want to do it in the game. So we have, you know, where was it? Oh. Right, so our string to float, our old one, it does some preamble stuff, right? And then it calls A to F, which is not good. And then also it copies it before sending it to A to F so that we zero terminate it. So this is like, this is not good, but then this is really not good. So we want to replace this whole thing. And so I think we're just going to put this in the game. Because I want to just, rather than try to reproduce whatever the optimization settings are for the game, that I might just make a simple mistake and it'll throw the benchmark off, right? I just want to put it in there. So I'm going to go main. We're going to go in here. And I'm going to go, where's our loads? We're going to go load really temporary. We're going to no check in that because we will break the game. Does that work? Oh, we have a main in here. We can't have a main in here. Let's take it out. Let's take it out. We don't care. Don't care about you, main. All right. It doesn't like that we are calling log. Oh. Like it doesn't realize that that's like what? We're not exporting anything called log from this file, are we? No. What are we using BASIC for anyway? Oh, I messed up N, guys. And I just wasn't getting a very good error message for some reason. There are some cases. Okay, no, it's just this happened first. So when we're importing BASIC into file scope, that's a compiler bug. But we actually don't need it here. We don't want it here anyway, so we'll not worry about that particular compiler bug. Okay. it might have something to do with, I don't know what it has to do with. Is the implementation expected to be round trip compatible? Mostly. Well, okay, round trip compatible, yes, unless you do something really, really weird. So this string parsing routine is supposed to be correct, except for weird corner cases where it'll have a 1ULP error if your source number has way more digits than it needs, right? So a lot of floating point parse. We actually talked about this with Sean on the stream yesterday. You could watch the VOD, but a lot of floating point parse routines just go bananas to handle things that people basically never actually need. But there's sort of a thing that is like the right answer of what you should do if your input number is potentially an infinite number of, decimal digits long. There's something you can do to generate the right floating point number. And the problem is, if it's like 10,000 digits, you actually, in some cases, have to look at all 10,000 digits and use like an arbitrary precision math library and stuff. So what we're going to write a big comment about this before we're done. I just want to benchmark it first. But this routine will not go that far, right? It'll give up at a certain point. That should be far enough for all practical purposes, right? Now, it's interesting that at the point where it gives up, there's little hooks where we could then call into a slower routine and have something that tries the fast version. And then if it realizes, oh, this is going to round incorrectly, then it could call the slow version, right? But I don't want to port a slow version right now. And I'm not sure that we even want that indefinitely. I'm not sure. Okay. Only one infinity. Well, I decided, I took out, we had negative infinity constants, and it's silly because you can just say that, or you can just say minus float 64 infinity, and it's shorter than typing out like float 64 negative infinity. So you don't need the negative infinity constant, is all I'm saying. Or do you mean the float 32? Yeah, we're not using float 32 infinity in this file, and I didn't want to require a dependency of a different file in order to get float 32 infinity, or to get float 64 infinity, right? So this is just redeclared locally to this file. And I just realized the file scope should be here. All right. So the game should run and everything. Now let's do a really stupid test. In our simulate loop, we're just going to every frame do a really dumb floating point test. That'll make our game slower for a bit, okay? So down at the bottom, we're going to go no check-in stupid float test. All right? Num iterations 10,000. Is that enough? It's probably enough. 40,000. Okay. Test old floats. Let's just do old floats and new floats. All right. We're just going to parse the same float over and over, which isn't a particularly rigorous test, but I just want Okay, old floats. And we're going to profile zone here. And then new floats, similarly. Like that. Okay, what is old floats going to do? F is... How do we prevent this from being optimized out? We say table old is 40,000. We can even compare later to see if they're the same. Right? Oh, not 40,000. The whole point of this number is that we use it, bro. All right. So we're going to write these to a global variable so that hopefully it doesn't get optimized out, right? What was it called? String to float 64. S. Equal F, right? And this is going to be string to float 64 fast. Table new. All right. Did I mean NI32? Oh yeah. Guys, I don't know what I'm doing today. None of this makes any sense. All right. So let's just see if this is on the profile. This is a debug build, so we don't exactly care. Oh boy. We crashed. What? Array bounds check failed. Really? Here. We're going off the end of the string. Okay. I don't know how we missed that. Oh, because it's assuming zero termination. I remember calling this out. All right. See, this is a little bit annoying now. All right. This is one place, like usually zero termination is annoying, but this is one place where it's a little bit better. Okay. Because you know, you will get a character that is not a digit, right? Whereas here, you just won't have characters. All right. So we can do that here. We can do that here. The problem is these things. So I'm saying len minus 1. Okay. So okay, this is a little bit annoying, honestly. All right. Okay. Maybe that's everything. I don't know, guys. Is the string null terminated? No. Oh, actually, wait, the funny thing is this one, oh no. Well, yeah, this one should be actually. Oh, look, we left a print out in. So we're printing 80,000 times per frame. That's great. Okay, what's weird is that string actually would have been 0 terminated. All right. So new floats is about the same speed as old floats. It's a little bit slower, unfortunately. But that actually doesn't mean anything because our new floats is full of array bounds checks and things like that because it's a debug build. And we didn't decide to turn those off. Good thing, because we caught a bug with one of them. Whereas old floats is in libc and it's like not doing all that stuff probably. So what we will do now is do a release build and see if there's a difference. If they're the same speed, I'm a little bit bummed. If they're the same speed, I'm a little bit bummed, but not that bummed because we still got rid of the libc dependency. The fail case here is if the new one is like way slower than the old one. All right. Let's see. Oh, stack trace disabled, guys. Let's put names. Whoops. We have to recompile for 30 seconds. Stack trace disabled. Why is libc dependency bad? Because we don't want to make a higher and higher and higher pile of semi-trash as you go into the future, because software will just keep getting more and more and more complicated and have more and more and more weird little problemy, glitchy things, right? Like you want to be able to have a clean, like if you build a new building, you don't want to build it on top of the rubble of the old building because it won't be as sturdy. You don't just like stamp the rubble of the old building into the dirt and then build on top of that. You know what I'm saying? Why are the counts sometimes non-integer values? Because they're averaged over some number of frames. Okay. New floats is about 4 times faster than old floats. Now, I'm not sure how much of that was that's really good for us. However, I'm not sure how, remember I had to string copy to a 0 terminated string so I could pass it to libc, right? Okay, here, the weird thing is this should have had a 0 after it. So this might have just been a bug in our code in a different way. Anyway, Let's call A to F directly, because we do happen to know that this is 0 terminated. So we're gonna do this. All right. I think we can just do that. Let's do debug build. Let's see if there's any speed difference in debug build. I kind of doubt it. I would expect. Oh yeah, oh wait, we put the wrong name. How do we know which is which? Is it worth leaving a comparison, comparing its result against C, A to F for a while? Maybe. Oh, wow. Wait, what? Really? Interesting. I mean, again, that's debug build. But like a lot of, so I wouldn't have expected that much of the speed drop of, I mean, again, it's debug build, so who knows? Like, there's array bounds checks in here. We're going over this string and doing a bunch of things. That actually means that the libc A to F isn't really that slow, because this in debug build is like dominating that, right? I don't know. Let's see. Maybe this eat spaces is really slow for some stupid reason. Let's do a release build. See what the real numbers are. Although actually I do care about debug build performance, because I run debug build a lot. And when we load animations and we parse tons of those floating point numbers, like we do hitch a fair bit. So yeah. No ABC time. Well, you know, you turn off array bounds checks for release builds, so it's not that bad, but all right. Okay, so yeah, most of that is probably array bounds checking or whatever in debug build. So our new floats is still, you know, it's more than 3 times faster than calling A to F from libc directly, which is great. We are paying for that with this weird rounding case, right? Streaming is one potential component. The VS is also running. Yeah, I mean, there's just, this is not a very scientific benchmark. I mean, also we're not testing cases out of the range of floating point numbers. This is literally the same number 40,000 times, right? But nevertheless, this is pretty good. Now the problem is, like I said, I care a lot about debug build performance, and debug build performance is not that much faster. Let's try, actually, let's try debug LLVM performance, because that was debug build x64 backend. Let's see LLVM backend performance, because it might just be, yeah. So we are adding, honestly, a good chunk of overhead. So if I care about debug build performance, I actually want to hit those functions a little bit either way. But I don't want to turn off array bounds checks right now, because it's new code that might have mistakes. So like, all right. As you can see, the x64 backend is substantially slower than the LLVM backend. Yeah, our new floats function is slower in the x64 backend in debug. We're going to want to tighten that up at some point. Okay. Is libc always in release build? Yes, I believe so. Let's actually, let's do this. I mean, this is going to be really dumb. We're going to go. We are going to go like this. A mod we're just going to do a bunch of floating point numbers. I don't think this will change the output at all. Whoops. I don't think this will change the output. Could I generate that table at compile time? We could. Okay, I used too much. Probably used too much temporary storage. You know what? Let's do that. Let's. Oh no, or probably. I don't know what I just did. I don't want to debug it though because it's stupid. Let's build it at compile time. Right? What's the best way to do this? Okay, make table input. Going to do that. We're going to do this. And then we're going to do this. Like that. So that should generate that table at compile time, which honestly is better because then we don't have to spend runtime CPU doing it. I probably messed it up. Not all control paths return a value. Okay, well, we have a compiler bug maybe? Hold on. Oh, wait, this is not how this works. Placeholder was never filled. Why? Our thing isn't running. Guys, I have a compiler bug where our thing isn't running. And I don't know why, because this isn't usually a problem. Okay, well. Oh yeah, I'm not, okay. I was getting my not all control paths return a value again. So shouldn't that be? Yes. Oh, you know, okay. You are correct about this, and there should be a comma. And it could be that we're throwing it a string. So sometimes right now we're not good at reporting parse errors, which seems weird because it seems easy to report parse errors. But we're not even running this actually right now, because we would get this. So there's a compiler dependency problem kind of situation. Hold on. Like, let me just try something. So sometimes we have a situation where, no, it's like literally, it's just not trying to run this one. Okay. There's something weird with run and insert. So if I do it this way, there's like a dependency missing. If I just say run this block of code, so now this error is just because we put hello, right? If I go to this output file, where is it? .build. It's going to say hello there, right? Line, well, it says hello here. Oh, that's our, okay, line 32. Yeah, so we just put hello here. So we can fix this now, hopefully, by just doing this. However, there is some kind of compiler dependency problem right there. All right. Oh, yeah, this. Okay, that's us printing it. Let's not do that. And then I think we don't like commas at the end, so we probably should allow that. Whoops. Numturations. Don't you know what numturations is? All right, we got it again. What's going on? We've got, maybe we should reduce this to like 20 for the purposes of being able to look at what's being output, right? Let's say 8. Okay. Oh, we didn't put a semicolon. We need to use semicolons every day, guys. Right there. Okay, finally. Why were so many errors when I had to type in num iterate? I don't know what you're... Oh. Here? It's a good question. Like I said, the undeclared identifier reporting right now is a little weird and just needs to be cleaned up. I've not ever seen this happen. So that's going to have to get cleaned up. But also this. This run and insert problem. All right. Let's change this back to 40,000. All this was really dumb because it's going to be the same speed. All right. But here we go. Oh, it did the same thing. So that's the same thing it did when we dynamically allocated strings, which means I just made a stupid mistake down here probably. Let's actually... Or you know, maybe we have an actual different bug. Okay, actually, here's my theory. My theory is we have a bug in new floats. Whoops. My theory is we have a bug in new floats. You know, why are we passing n? We're not using it. This is silly. My theory is we have a parsing bug in new floats that we didn't... oh, this wasn't even... Haha. Okay. We can do this. I'm actually not sure why that wouldn't work, but... Okay. Finally. Will this not crash? Maybe. Yeah. So the bug was not in our setup code here. All right. The bug was in the new float routine. So let's debug it. We did something dumb. One of these cases is exercising something. So we will find out. Of course. Oh, well, we have to... So, okay, the problem now is I think we're generating different numbers every time. Oh, or maybe it's an x64 backend only problem. Let's see if that's it. Because we fixed an x64 problem yesterday. No, either we did something dumb that I fixed in the code cleanup here, which is possible, or we have a crash that only happens for some numbers in the new parser. A to F is still wrong for input given to it? What do you mean? Oh, you mean from before, yeah, okay. Okay. Well, here's what we can do. Let's see if this works. Let's go to this. Let's just name this, it's I. Okay, assert table old I. This may well not work, right? Okay, let's generate the same random numbers every time. Because actually we might be, but let's make sure we are. Okay, so we're going to say hopefully that's a relatively prime. All right. So, is it going to work? It's not asserting, guys. Which means either I messed this up or our things actually match for all inputs that we generated, which is certainly not the entire floating point space. Well, this is kind of okay. Let's now. Okay, let's start using the Llvm debug because this is at least, you know, for reasonable speed things. We can try no ABCing the new code and see what happens. Like we would like to get new floats. It's a little bit faster than old floats right now. But it's also like not doing a string copy. So we would like, I mean, it's a fast string copy, so that probably doesn't matter that much, but we would like, I mean, we could just do this and see what happens. In the shipping case, will the text floats be binary? Yeah, we won't be parsing these in release build. This is just for during development. You know, we got slightly faster with the no ABC. Not huge faster, but I mean, it's only honestly twice as slow as something where all that equivalent code is in libc and release build. Well, okay. And actually, I think we're paying significantly for array bounds checks like here. So let's just see how long this takes. And let's put no ABC here. Because when we're measuring the A to F, we're measuring bounds checks on all this stuff and whatever, which is going to make A to F appear slower a little bit, maybe a lot. Yeah, so that was like 1/3 of the runtime of almost all of these was those. We got to get faster array bounce checks, honestly. So I guess there's an error in iProf sometimes, like, oh, no, that's because sometimes we call simulate a different number of times if the time step is weird. So that's goofy. Okay. So this is also, we're doing 40,000 floats 3 times per frame, usually, sometimes 4. So I mean, you could do, and we're doing 3 tests, right? So in a debug, this is a debug build. This is how fast computers are, all right? This is a debug build of the game. We are doing 360,000 float parses per frame. And the game is still interactive. I mean, it's not fast, but we're doing 360,000 float parses per frame. In debug. Let's do 360,000 float parses per frame in release. Is the plan to implement the float to string conversion next? I think we already use STB for that. We might port it to be native, but we already don't use libc for that. Yeah. So this is, just so you know, this is how fast computers are. All right. Here we go. We're at 60 FPS, 60 frames per second. We are parsing. Oh, wait. Actually, it's a different number per frame because we're going too fast, right? So we only do 3 sim steps when our frame rate is lower. So, okay, we're parsing 120,000 floats per frame for no reason. And we're running at 60 FPS, all right? With like drawing graphics and stuff. So when you try to like scroll your web browser and it doesn't scroll very smooth, or when you like type the address into your address bar and it like does some janky stuff and then does some network and then some janky stuff and then some more and then things slowly, like there's no excuse for that. When you visit the Steam Point store, it uses like 50% of your CPU to draw some animated pictures. Yep. Steam thinks animated pictures are the future. Maybe they're parsing 1 billion floats. They could be. They could be. We're also doing this loop. I guess it's not doing anything because assert is... Actually, we might have asserts enabled in release build. We do have some asserts enabled in release build. I don't know if the default assert is. So new floats is faster than A to F substantially, which is great. Let's make it the default and then start documenting. We also have to take notes on the things that went wrong here. So I was not happy about this. So let's just verify. If I do this, okay, hold on. So this run and insert works, but the following does not work, right? If I do this, this is supposed to work. You're just putting a function here, right? And there it is. This doesn't work. So there's a basic bug in run and insert. Why is this? That should be in Sokoban. Okay, that we've got to do. Unfortunately, we have some higher priority things that need to happen. But that has to get fixed eventually. All right, so we've made a note of that. Okay, now that we've made a note of that, let's comment out all this stuff, our stupid test. Let's make sure we still compile. I didn't do any. Oh, we got to not call it. Got to not call it. All right. So now let's go to our file here. And we're going to make it a new file. We're going to go to modules, basic. We're just going to make a file called string to float 64. All right. Dump that. We're going to take off the word fast. Whoops. Whoa. Come on, Emacs. We want to comment both of these. Both of these bits of source come from different places. We're going to need to put a copyright notice in there according to the license because it's a derivative work. All this stuff. Okay. So I'm going to go to here. So string to float 64. Yeah. We actually, okay. Result remainder. We return a result, a success, and a remainder, and I guess that's a good idea. So turn 0 false, 0 false. Okay. Okay. Great. We are going to delete this. We're going to delete this. going to go there. Did I not write the file? Oh, I called it string to float 64. Whoops. Let's also check it in. Okay. Well, now we're using that by default for all floats. Let's see if we explode. I mentioned some interview questions I thought were reasonable. Do I remember what the company was called? It wasn't a company. There's a YouTube video of Casey Muratori doing a mock interview with Sean McGrath. That might be what it was. Or, oh, wait. No. You mean, okay, I saw the test. I think it was Tiny Build's interview questions test. That one. Like it was like a paper test where they asked people to submit. That was actually, it actually wasn't bad. Have you tested floats with exponents? No. What do I think about Git? I don't. Okay. This is great. I mean, we're loading this animation now with the new float routines, and it looks good. It's loaded a lot of floats. Loaded a lot of floats. Benny test, maybe. Let's fill out the file and stuff. Oh, the other thing is, this had all this stuff down here was just to load A to F. So we're getting rid of that. Oh, we should run tests, by the way. Haven't done that in a while. It's always scary when you realize you haven't run tests in a while. Some of these use string to float as well. What format are we using? It's just our own format. Do we have an in-house editor? If you mean for meshes, no. We just use Maya or 3D Studio Max, and we have an exporter plugin. Assuming we have a parser for FBX, no, it's not worth it. Why not save the animation in binary so I can look at it if something is wrong? And also in principle so that you can diff it, but that's not that important. And honestly, as a system gets more mature, it's way less important to look at the file to see if something's wrong. Like I almost never do that. So it's not that unreasonable to switch to a binary format. I don't think Valve's biggest problem is what programming language they use. Okay, so oh, you know what else I want to do? Maybe we're going to do this in the afternoon. Okay, all this code, the mul96 and normalize and the stuff that uses it to some extent. It's actually not that bad when you cut out everything else though, but like, you kind of wonder what it would look like if every number wasn't 4 different things. Like, would it be neater? But honestly, that wouldn't affect most of the code in the file, so maybe it's not worth doing. Are we planning to remove libc dependency completely? Yes. You should not depend on libc if you're a different programming language. What about operating systems where the only way to do syscalls is through the approved libc? Then that is the fault of that operating system. That is not my fault. My job is to make it not my fault, honestly, right? I mean, some people say not my fault when it is their fault. My job is to make it not my fault that you have these stupid problems, right? So, when it comes to Linux or whatever, it's Linux's own stupid fault that, let me try to think of some stupid ass libc function. I actually don't know where fopen lives, but that like fopen is in the same place where the code is that you need to do system calls. Oh, that's not Linux. Well, I believe that is the case in Linux, though. Like people do say, oh, you need libc and whatever. And it's like, oh, well, sure. But the point also, so there's actually 2 different reasons, right? So one is the pragmatic reason of not being subject to like tool chain issues, right? Like, oh, I can't distribute a binary because somebody else has a different libc that gets dynamically linked on their system that doesn't have all the same symbol. Like all that stuff is terrible, and you avoid that. if you don't use libc, right? But the second thing is you just don't want to be carrying the weight around of that code and how it functions. You know, a lot of that stuff was designed in the 70s. Computers are different today. And so, well, and not just that it was designed in the 70s, but like I take a substantial degree of issue with like what is considered the Unix philosophy today, right? So like if you just keep using the old thing, it's kind of hard to do something different from the old thing. So that's the other reason. Some BSDs do that. Yeah. I mean, like, look, it's very not forward thinking to tie all this libc code, much of which is quite low quality. Have you looked at GNU libc? Oh my God. Right? So much of the code is of a quite low level of quality. And you're going to say that every program indefinitely into the future has to have all that code in it? That doesn't make any sense, right? Don't syscall IDs change? They're not supposed to. So my understanding is that, for example, the Linux kernel maintains compatibility, right? Wherever possible, right? That's one of their core, it's one of their core tenets, right? And it's the user space people in Linux that are jackasses and break things all the time. That is what I'm told. I don't know. GNU libc is quite performant, though. No, I disagree. I disagree. According to who? I mean, you just heard that, right? But like libc, the reason I disagree is libc is just not the fast way to do anything, right? Like if you're going to read files, if you're going to read files fast, you don't use libc, right? If you're going to, what's some other, I don't know. I had something else, some other example I was thinking of, and then I dropped it. Memory, well, okay, memory allocation is a great example. If you want to manage memory quickly, you absolutely do not use malloc. I don't care how fast you think your malloc is. You don't use it. How is this compiler fast? It doesn't malloc. Hardly ever. Like, and so saying libc is performant is, I mean, fine, but like, that's not what the people who know how to write fast code actually use anyway. So it doesn't make sense. And so you're trying to squeeze this bit of performance out of code that actual performance people won't use, and seemingly making it very ununderstandable in the process, which, by the way, is also not really necessary. Yeah, I need to do a whole speech at some point about why I think the current interpretation of the Linux philosophy or the Unix philosophy is bad, broadly speaking, and will not take us into the future in the way that we need. Linux kernel now has klibc as a project. You don't need to depend on glibc. Yeah, but I don't want to depend on any libc. What do you use, heap alloc, or is there a more low-level call? I think so. So right now, I'm pretty sure we do actually call malloc, just because that's easy and cross-platform. We call malloc, but we malloc in very large blocks, right? And almost all of our actual individual memory allocations are, pooled memory allocations or arena allocations or something like that, right? So you don't actually call malloc. If you're going to allocate 100,000 things, you maybe call malloc 10 times, right? You don't call malloc 100,000 times. And so the speed of malloc suddenly doesn't matter very much. You think the motivation of going through a reference libc to get to syscalls is for security reasons? How does that add security? I thought the way that you do syscalls in Unix is you set some registers and then sbreak, right? You can do that in machine language. So there's no security. Like, the security has to be on the kernel side. Let me put it that way, right? libc is better because it is portable. You mean in terms of system calls? I mean, sort of, but like, there's nothing stopping anyone from making, like the way Windows works, here's the system calls, here's the library that just has the system calls, and this is portable, right? And then here's the library that has libc. Like, that's the way to factor it. And for some reason, Unix people have never gotten off their ass to do that, so. As we said, we use malloc from libc because it is portable. Yes, but if I don't, what am I trying to say here? The compiler where we use malloc from is in C++, right? So clearly we're using libc unless we're getting bananas, right? If the compiler were not in C++, if the compiler were in Rust, I would not want to call malloc, right? And I would not want libc under me. It's a different thing. Different thing. This is what you're talking about. Let's see. OpenBSD system call origin verification. Yeah, I mean, okay. This is a totally reasonable, like, if you want to increase security by doing something like this, that's totally reasonable. But why are you putting that in libc? Just make a library, like I said, make a library that is, okay, here's the problem. Here's the problem. And it goes back to the fact that, in the beginning, C was a very lightweight programming language. right? And Unix was a very lightweight operating system. Okay, and they were sort of developed together. And so, like, libc was initially largely kind of the way that you interface with the operating system. And then more and more over time, it got added more and more things that were heavyweight in the sense of like what we now consider a programming language runtime, right? So libc has always had two things in it. It's had operating system interface and language runtime. And then once you got to C++, the language runtime part just blew up insanely, right? Now, sometimes there's a gray area, right? So like, you know, who's to say if you're calling read on a file descriptor, if that's directly supposed to be a system call or if that's a language runtime or whatever, right? But the way to have things be clear and understandable and debuggable and more portable and future proofing, right? Or making things so that you can build on them in the future. The way to do that is you separate those two things very clearly. You say, here's the library for interfacing with the kernel, and here's the library that is the runtime for the language, right? And those are different things. And then if you want to do your security verification, like in that BSD write-up, you do it from the kernel interface library, right? Same thing. It's essentially what Windows does, except like Windows is so bananas, their kernel interface is just really, really, really large, right? But that's what they do. That's what kernel 32.dll is. And that's actually the right design. Unix is the wrong design. Unix is, we had a design that seemed minimal and simple in the beginning, and it didn't age well. That's all. But like, you know, people are set in their ways and nobody wants to do that, even though it's the way that you need to do it. And then the other thing to say is, of course, there are way more syscalls than there should be because we do way more things with the kernel than we should, and that's becoming obvious both for performance and security reasons in the modern day, right? Like, you don't want to go to the kernel to do everything. Like, if I want to talk to the network card, I should talk to the network card. I shouldn't go to the kernel. The reality is that in the end, everyone links to libc one way or another currently. Not everyone. Some people go out of their way to avoid it, but yes, pretty much everyone does. And so there's not that much, let's say, motivation or political will to clean this up. Yeah, I agree that that's the reality, but it also creates this ongoing mess where you can't distribute a binary, right? Why? Why can't I distribute a binary reasonably on Unix operating systems, even though in the cases, for example, of Linux, I don't know about the BSDs, but in Linux, again, they work really hard to keep the kernel interface stable. But yet I still can't distribute a binary. Why? It's because the user space people, the people who change libc, the part that's not about interfacing with the kernel, those people mess it up. You got to be able to get those people out of the loop if you want to be able to distribute software, right? Now, of course, then there's political reasons why people say like, oh, you should never distribute binaries and whatever, and that's wrong as well. It's just a mess, right? And that's why it's one reason out of many why I got to make my own operating system eventually. Pretty sure some consoles used to run variants of some BSD and was wondering what my plan for those is. Assuming they end up using this go through libc thing. I'm actually not sure. I'm not honestly sure what all the console operating systems are based on. I mean, Xbox is obviously Windows. PS4 and PS5. I honestly don't know. Maybe they're BSD at the bottom. Someone's saying you want to write your own network stack and driver for unpredictable PCI Express cards for which you sometimes don't even get any docks. No. No, I don't want to do that. And that's fine. Like, you're assuming that the problem statement is what you're assuming it is rather than what I would make it be if I made an operating system. Sony's BSD based. Yeah, I'm not that surprised. Okay, let's actually do some of this stuff. So we have 2 bits of code here. The stuff at the bottom is a fast 96-bit multiply. Let's just start explaining. The code here is a fast 96-bit multiply from, what was this called? It was from Llvm by whoever. We got to go find the Llvm. Oh, we have it on our drive here. Downloads. Llvm. Okay. Okay. From Llvm version 4.9.5a by Michael C. Ring. The code below Llvm is a fairly extensive library, and we only extracted the part we need here. So we need so we definitely need to reproduce this. And I want to do it because we might actually pile up a bunch of these. I want to put it in a file, like a README file in the module, but that doesn't get compiled every time because it could end up hundreds of lines for all I know, right? So let's just say there's going to be copyrights.txt, all right? Copyright for the Llvm code used in float or string to float. Like we could try putting this in a comment in the code, but I prefer to not have it be compiled every time. Look, oh, it's tabs, dude. Uh-oh. We're getting hosed by tabs. How do you convert tabify and untabify? So I can go metax untabify? Okay, well now it's spaces, but at least I could do this. Okay, Michael C. Ring, we fixed your copyright notice. I guess I should put this part as well. Okay. So there's that. Let's add this to source control. And then did we remember to add our string to float? Oh, yeah, we did. Okay. So going back to the file, C copyrights.txt for copyright info. Okay. We'll leave that comment there. But we only use 2 of these functions for now. So it actually doesn't matter much. But if we use more of mapm eventually, this may become more of an issue. And it'd be worth seeing if there is a performance degradation due to using structs for the numbers. Okay. Wait, am I not allowed to modify this license by putting spaces? It says permission to modify. Okay, wait. To be distributed by using the file license.txt as a template to modify the file header. I don't know what that means. To distribute modified source code, insert the file license.txt at the top of all modified source code files. Okay. Actually, so we can't just have this. He actually insists that the compiler has to be slower by chewing through comments, which is, I guess that's what happens when you use someone's code. All right, we got to find that. Where's license.txt? Is available in the official, is it? I don't see a license.txt. What? I guess this is it, but how do I know that? License.txt is available in the official but it's not. It's not available. What if your language didn't support comments? That's a good point. Okay. Okay, let's go back. Let's put this in. Like, actually, this doesn't have to be here. It's weird. This is what happens when you're not a lawyer and you combine different things. So that other README says I have to put all this, but this says I don't have to put this in the code. The other README says I do have to put this in the code, but this says I don't. This says this only has to be in documentation and this only has to be in the code. You see what I'm saying? It's like it's mutually contradictory legal constraints. Oh, somebody found the license.txt. Oh, okay, here we go. This is, okay. Do I have to update the date every time I change a character? It's originally from Llvm version 495. Like, he's assuming that it's an entire file, whatever. Let's do this. And then this is the description of the changes. Okay. Whatever. I mean, I think he's just concerned that you don't take the code and claim it's yours, right? Or that you don't take the code and mess it up and distribute an inferior version, and then there's no way for people to know where to get the official version from, right? Which is all totally reasonable. It just gets weird sometime when you have to comply with the actual... The new header makes no sense. Yeah, I mean... Let me do this, because this explains in more human terms. However, the license for the code requires that I also include this somewhat less understandable comment. Okay. I shouldn't, I'm just going to say, Okay. Hopefully we are complying. I hope we are. Okay, so now we have to do a similar thing, but different, because this code is from somebody else, right? Who is using MapM. I'm going to have to look at MapM later because I didn't even know that that was a thing, right? Although, so I still have open one of the alternative float parse functions that we didn't look at. They fall back on the standard library for the difficult cases. Okay, so that's not really different from what we're doing. It might be faster. So here's an alternative library that may possibly be faster, but that also falls back to libc for hard cases. Okay. Okay, so let's put this here. We're going to say here string to float is just calling string to float 64 and then rounding. This is not correct for some edge cases as you can. Okay. Okay, let me just, I'm going to write a big comment up here that explains what even we're doing. Okay. How to explain everything the code in this file converts from strings, parses strings to yield floating point numbers. This is how do I say it? Solving this problem exactly for arbitrarily large input strings can be very difficult and slow, involving arbitrary precision math. The convention in recent years has been that programming language libraries handle these cases because it's the right answer, even though almost nobody is ever going to call a function like this on a 50,000 character input. And those who do would probably do better with something. That might not be true. Okay. The code below doesn't try to do that. It should round trip correctly with any output of any other correct system that is that prints enough digits to uniquely identify the floating point number. If there are many more digits than that, then in some cases it may round incorrectly, giving you a 1 ULP error. Do we want to fix this in the long term? I am not sure. On the one hand, the principle of least surprise says that the code should just do what you ask it to do and not have weird constraints like this. On the other hand, if the resulting code is much more complicated, it incurs a burden on everyone every time they compile and link the code, and it makes the source code less friendly, harder to read, and more like a scary thing that lives in the basement, and we never want to go down there. And long term, this kind of added feeling is a big part of what's wrong with software. So maybe the correct, bigger picture decision is to live with the 1 ULP error on weird inputs that nobody is ever going to use. I am not sure. Okay. So here we get to the code from D to A fast. This is really maintained. This is like updated 5 days ago. Okay. MIT license. Okay, so we're going to put this in our copyrights.txt. Copyright for the float to string for, what do we call it? String to float 64 code. Okay. So then here we say string to float 64 I want to rename this function stir to decovit, and stir to decovit are translated from the D to A fast library. Okay. We picked this code library because it looked reasonable, but did not perform an exhaustive survey. Okay. Okay, so stir to decovit. Let me just say, I'm just going to call this string to float helper. We'll just call it helper. Because like, what's, I don't know. I don't know what to call it. What does it do? So do we even need the string here? Why are we passing the string, by the way? Was it just for debug printing? Like, okay, hold on. Can we just do that? Whoops. Oh, well, we have to not pass it. Okay, we didn't need that. It might have been for debugging at some point or whatever. So basically we have the number, but it's in one 64-bit and one 32-bit chunk, right? Which is a little bit weird. We have the base 2 exponent, the base 10 exponent, and whether it's negative, right? Do we use the base 10 exponent? Yeah, we do. Or no, this is not, right, this is, oh yeah, this is times 10 to the whatever is what's in that table, right? Okay, we can insert our own debug prints at some point. Okay. So this does the multiply by power of 10. It's like multiply by power of 10 and convert to float. All right. Okay. Mike passed away in December 2011. Oh, man. Bummer. Oh, we're not. Why are we using MapM 495 if there's a 5.1, man? I don't get it. All right. So okay. So that's the where the provenance of this code was, which is great. Now we've added like 50 lines of comments. We got to comment this thing. If I understand correctly, these cases marked precise rounding represent the points at which the only points at which this code gives up and potentially yields the incorrect rounding. At these 2 points, we could call into an arbitrary precision routine to yield the answer. I believe the original does that code have, or sorry, D to A fast. Yeah, it uses MapM. Okay. Okay. Okay, I feel like that is everything that we need to do for now. And we can check this in. Woof, look at that table. almost want to, like, I wonder if we end up having lots of big tables, you almost wonder if you should specialize your lexer. Like right now, we return a separate literal for each one of these. And you almost want like the lexer to have a frickin' array literal, you know? Except the problem is somebody will put a hello sailor in the middle of this and then you're sad. Okay. Good job, everybody. Good job, everybody. We are now running with the new thing, and I actually wonder if we Benny test in debug, how hitchy will it? Well, like if I go to, like this is a debug build and it's not hitching that bad when we like load animations, which is weird because I thought our x64 build was a lot slower, but a lot of that might have been in the loop, right? The debug build, I mean. Like, I'm not seeing hitching when I load animations here. Well, I mean, tiny hitching, but like here, that loaded a couple animations. And yeah, there was some stutter, but it was not as bad as it was before. Yeah, so that's loading some animations. Not nearly as annoying. So like if I Benny test things in full-on debug build, well, we'll see. Let's turn our test speed. Now, you know what? Actually, here's the thing to do. We were at 3 minutes and 15 seconds for a full Benny test before in release mode. So we could see if that's actually faster noticeably. Or I think we were at 313 and a half.
Today we're going to talk about how to transport a firearm.
What is going on, man? YouTube is just playing videos. Okay. Reset. No Vulcan. We're in progress of doing DX12. But it is not done. Okay, so 120 test time rate. All right, ready? Go. So if we can get a noticeable number of seconds improvement out of this, that'll be great. Does that 100K lines compiled include the library functions? Yes. That is a full compile of everything every time, including all modules used by the code. This is like a task speed run, sort of, yeah. We're just testing the game. Are there unit tests for the standard library? There are a degree of unit tests, yeah. Do I think a C program similar to this with similar constraints would compile similarly fast on TCC? I think it would be faster. Because we spend a lot of compile time on high-powered programming language features that you don't need to support in C. So you could actually compile a lot faster, a C program, easily. No, we didn't have a test like this on the witness. How do we test the witness? We just played it a lot. We hired testers to play it a lot. Andy did make a thing where, 309.5. So we saved between 4 and 5 seconds off the full Benny test by substituting that float parser because of loading animations. So I almost missed. Fortunately, I looked over at the stopwatch in time. So we're at 309 for the Benny test. Do I think the witness could have benefited from a system like this? Not really. It was not the kind of game that is testable in the same way. All right, I think we commit this. I also made some other replace the float or string to float code with something that no longer has a libc dependency and also runs substantially faster. Substantially faster. All right, I'm going to push the button. It's scary. Oh, we have a no check-in in string to float. I thought we got all of those. Oh, okay. I did test this before the stream. Minus 0.0 works, but if you say minus integer 0, that does not work. So we have to fix that. I'm just going to put that. Okay. I'm going to put that in the compiler to do. That is important. Okay, this one, this is the last no check-in. Okay, this is something about okay. This apparently has enough precision to reproduce the correct exponent for every entry in the, what was the table called? Fast BF96 table, so that we don't have to store those exponents in the table. Right? Right. Let's make sure that still compiles. Okay. Boom. Committed. Do I recommend Game Engine Architecture book? I don't know anything about it. I do not know anything about that book. There actually were some automated tests on the Witness for specific subsystems as well. So like we had a test for subtitles that they wouldn't go off the screen and stuff. All right, everybody. That may be it for the stream. We did what we set out to do. Is there something interesting involving prime numbers in game development? I don't know, man. I don't know, man. What are you supposed to do for the rest of the day? Fix computers. How much libc dependency is still left? For our transcendental math functions, we definitely still do. So like sine, cosine, tangent, arctangent, all that stuff. However, a lot of that, I believe, has just CPU instructions that we could make intrinsics for in the modern day. So like, why pretend that you need to have, you know, C code that makes cosine? Although I need to double check that. I need to make sure that they're full precision and all that stuff. Then, I don't know. There might be a couple others hanging around. Honestly, I don't remember if we call malloc from libc or if we link one. We shouldn't do either, right? But for now we do. But there aren't that many more dependencies hanging around. So like files we don't. I mean, unless of course you're on Linux where you have to, etc. Did it fix the precedence of that operator? No, that is a much more major operation because we would break the compiler for every beta user and stuff. So I want to think about it. I want to make sure, you know, that we're going to do the right thing and notify everybody. On ARM, that is probably not the case. I don't actually know if it is or not. And we don't target ARM yet anyway. Right now, we only care about x86. So like, if we have to include a math library that you only compile on ARM, then that's fine as well. How do you return multiple values from a function? Same way you pass multiple arguments to a function. Doesn't cut off a lot of still good older CPUs. We are 64-bit CPU only right now. We do not target 32-bit executables, period. New Macs, I don't know. Like, look, like I said, we only care about x86 right now. That is all we're doing. We're doing x86. When it comes time to do ARM, which probably will happen, we will do that. But we're not doing that right now. I thought we got it working on the Switch. Isn't that ARM? Actually, that's a good point. So I guess we did do a little bit, but it's not official right now. How the Benny test went? It went good. Oh, new failure? Question mark. I don't know. We definitely have some failures that we added yesterday for good reasons. That's about what we expected. So we didn't get any fails due to replacing the float. Although that's a good point. Thank you for asking that because, yeah, that's relevant. So many game companies require a computer science degree. Do you think it's necessary? I do not think it's necessary. And I think if you were to go to most of those companies, if they're good companies, and say, hey, look at the things that I've done that are way better than what most people out of college do, then they won't care if you have a computer science degree, honestly. All right. Thank you, everybody, and I'll see you later.